Hello, hi. Hello, hi, Chitra. Am I audible now?
Yes, yes, you're audible.
Hello, am I audible? Chitra, if you can let me know, I can proceed.
Yeah, you're audible.
I'm audible. Yeah. Okay. So, hi guys. So we are waiting for the Saturn Jupiter conjunction. Jupiter is already visible from the skies here. I'll be trying to focus right away. Okay. So the sun has just set about 15 minutes ago. In about half an hour from now, we can see Jupiter and Saturn really close to each other in the sky. Right now, I'm able to see Saturn, Jupiter in the sky, but I'm not sure if you're. I'll try to focus it on. Give me a moment or so. But yeah, so I'll first we'll observe a lot of things. We'll observe the planets, we'll observe the moon, and I'll talk about it. Then I'll probably once we establish the first view of these things, then um first then we will learn about how these conjunctions happen and how rare they are and how they occur and all those interesting things, and also I'll be taking a lot of your questions on this particular event. So today, before I view on the planet Jupiter and Saturn, which is clearly visible right now in the sky, I would like to say that there are two important things happening today. One is, of course, this great conjunction, which humans are able to see it after nearly 800 years. Of course, they're able. This event itself is happening after nearly 400 years. But last time it happened, the conditions were not favorable. Like it did not happen during the time where it could have been seen by humans. Okay, so. Last time humans saw it was in the 12th century. So we are saying that we are seeing it after 800 years. That's of course an extremely rare event. To add on top of it, today is what we call as a winter solstice for the people in the northern hemisphere, and it is summer solstice for people in the southern hemisphere. So for us northerners, northern hemisphere, people residing in the northern hemisphere, this is our shortest day. If you've observed, the sun has set by 6 o'clock, and sun rises only by 6:43 or 6:45 in the morning. So we have roughly about 13 hours of day, 13 hours of night, and about 11 hours of day. So this is our shortest day and longest night. So in that sense, this is also special because this event is happening on the day of winter solstice, which is like super rare. The conjunction could have happened on any day in the 365 days a year, but it happens to be on this particular day, so making this event an ultra rare event. So right now, let me try to focus on Saturn and Jupiter. um, Chitra, for now you can I'll mute myself and stop my cam. Once I bring Saturn and Jupiter into view, I'll probably you can pull up those screens and show it to our viewers. Okay, please be patient because the sky is still not dark enough for us to enjoy the view yet, but it is going to get darker very soon in about 20 minutes or 25 minutes. Okay, so I'll mute myself and stop the cam, and I'll try to focus on Jupiter and Saturn right now in the camera view. Hi, Chitra, am I audible?
Yes, yes.
Yes, yes.
There seems to be an echo. Yeah. So okay, right. So I'm audible. Good. Uh, yeah. So hi guys. You're seeing on the screen Saturn and Jupiter extremely close to each other. Hope you're able to see it. Chitra, is it visible to your screen as well? On the screen, you can see it, right? Let me focus on that.
Yes.
You can see two dots extremely close to each other. The brighter one at the bottom is Jupiter, and the one to the right of it and slightly above is Saturn. It's extremely close to each other, as you can see. Let me brighten the screen up a little, so you'll be able to see it better. Just give me a moment. Hi guys, I hope it is visible. I'm trying to in a while from now I'll be trying to bring this into telescopic view. Please bear with the time because it takes time to set up. But right now seeing the view through the camera. Zoomed in at 250 lens. So yeah. So this is the view that I have zoomed in. Let me zoom out and show you how it actually looks like. Probably let me set it up at 55 and I'm not sure if you're able to see it. I put it in the box. So probably at this level of zoom in, you are not able to see it at all, I guess, because you can see Jupiter still, but only if I'm able to zoom in a little. And let me zoom in a little bit. So now you can see. Look at how close they are. So now they are close by like less than a degree. Okay, so you can imagine the entire sky to be split into 360 degrees. Of course, from horizon to the other horizon, you can imagine it to be like 180 degrees, like a semicircle. So overhead would be 90 near the horizon, the point where the land appears to meet the sky. Horizon is at 0. Overhead would be 90. Then as you go past overhead, it's like 100, 110, and goes on till 180 at the other horizon. So you can imagine the entire sky to be 180 degree. Now planet Jupiter and Saturn are less than a degree apart. The separation between them is less than a degree. In fact, it is 1/10 of a degree. You can imagine how close they are. Now I'm zooming in further to see if you're able to see them. I hope you are able to see it still. Chitra, is it still visible? The two dots, Saturn and Jupiter, close to each other?
Yeah, it's a little faint, but it's visible.
So now I'm zooming in further so you can see it a little better.
Yeah, it's visible now.
Yeah, it's visible now. It's visible now. So look, only at a certain level of zoom we are able to see it. So which is like interesting because to the naked eye, I can still see it with my naked eye. I can see they're right next to each other. If you are out there, you can see it, they're right next to each other now. Yeah, but through a zoom camera lens or a binocular, you'll see them like really separated apart. This is probably the only time where you can see both of them to be close together to each other in the sky in one single frame. Now I'll try to shift to the telescopic view. Okay. Yeah. So I am getting my other camera ready so that I'll try to show the telescopic view of it. Just give me some time, Chitra. So till then you can look at these two planets how close to it. Then I'll once I set up the telescope, I'll explain you more. And Chitra, please let me know if they have any questions about it. I'll tell about it. Yeah, I'll answer them. Just give me about 5 minutes to set up the other. In the meantime, you can keep looking at this particular view. Okay, I'll center it so that yeah, I no, I that is fine. But you put the lens in see lens. Yeah, yeah, right. Right. No problem. No problem. Okay, back to this. Cable உள்ள மாட்டிடு. Oh, in the okay. So the light is on the side. வந்துருச்சு. இத லைவ் போட முடியாதா? லைவ் போடுறாங்க. டெலஸ்கோப்பியும் போடலாம். ஆமா. அது ஃபர்ஸ்ட் கொண்டு வரணும். Just think to move. Close இல்ல. Just check on the screen. பார்த்துட்டு போடு. மூணு ஃபோக்கஸ் பண்ணிட்டதுக்கு அப்புறம் இல்ல ஃபோக்கஸ் டிஸ்டன்ஸ் ஆகும். மூணு வரதான் அப்புறம் அதுங்க சார்.
For the up, like, move it up slightly and right.
Right one. To your right one.
ஏன் ரைட் வராது?
Right பண்ணு.
அது போகும். இது கொஞ்சம் இடம் வேணும். இதே டைரக்டா பண்ணலாம். அந்த இன்னும் டெலஸ்கோபிக் இல்லையா, அதையும் எடுத்துட்டு வாங்க. Just quickly bring it. இப்போ வரும் பாரு. அந்த டெலஸ்கோப் செட் பண்ண பிரியா. செட் இட். செட் பண்ணு. லென்ஸ் ஏதோ ஒரு லென்ஸ் போடலாம். லென்ஸ் ஃப்ரீ அந்த பேக்ல, குட்டி பேக்ல இருக்க லென்ஸ் எது. Just take it. அதெல்லாம் பண்ணலாம். அதெல்லாம் அதுல நான் ஃபோக்கஸ் பண்ணிடுவேன் ஈஸியா. இதுதான் கொஞ்சம் ஆல்வேஸ் I'm not able to move at the time. அதுல நான் லென்ஸ் போட்டு போட்டேன். ஒரே அதெல்லாம் கரெக்டா அதுல செக் பண்ணிட்டேன். எனக்கு இடம் பின்னாடி நின்று எனக்கு நான் அதெல்லாம் யோசிச்சிருக்கணும். ஒரே மூணு மட்டும் வரதான் போறது. லைட் போட்டுருங்க. லைட் ஏதாவது வருதா பாருங்க. அதெல்லாம் வருது. மூணு வரல. ரைட் போகணும்னு நினைக்கிறேன். Some light. No, 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 no. Wait, yes, wait. Go back that way. Yes, you got the moon. It's out of focus. Okay, now.
மெதுவா மூவ் பண்ணுங்க. Stop. Stop. Just stop.
Okay.
You come back in the screen and then do it back. இதுல வந்துருச்சு. Telescope வந்துருச்சு.
அவளோட இந்த விட நேம் பறந்து முடியாது இல்லைங்க.
Chitra, check if the other screen is visible where I'm brought Jupiter and Saturn. Can you check it out? Pull out the other. Chitra, can you pull out the other screen?
It's not yet visible, Obli.
Chitra, check now, Chitra.
Yes.
போயிடுச்சு.
It's visible now.
Yeah.
Bring it back.
Let me bring it to the center of the screen.
தெரியுது.
Are you able to see the ring, Chitra? Saturn's rings, and is it reasonably clear?
It's very faint.
The battery is going to
And actually more of it.
yeah, on the battery. Pull out the battery from that camera, please.
Okay.
And we'll put it here. We're able to see the ring, Chitra, a small ring and Jupiter. Right now, what you're seeing is Jupiter and Saturn in one single frame. They're really close. I'll probably try to increase the magnification by changing the lens. Just give me a moment. But right now, what you're seeing is the view of Saturn and Jupiter in one single frame. And I'm not sure if you're able to see the rings of Saturn clearly, but you can see it's oval shaped. Yes. And of course, you can see Jupiter as well. Just give me a moment. Give me a moment. I will change the battery and the lens and show it to you guys. Take a 15 mm lens. 10 mm lens. 10 mm lenses.10 mm for 15 mm and 10 mm too difficult to handle. Chitra, you can pull out the other view. Oh, I think that's not there, right? Okay. Anyway, we'll see.
ஒரு செகண்ட் நான் லைட் டார்ச் ஆன் பண்றேன்.
Yeah.
அது 20 mm.
Battery, bro.
Yeah.
You put it on. Put this on charge. You need to spend a lot of money to get all the equipments in it. I cannot just. Okay.
Is it moving down? So just move it slightly down if it's setting. Okay.
Yeah. Priya. Priya. The 10 mm lens workout agadu. We'll try another thing. And in the is it Priya? இங்க பாரு இது 20 mm. Okay. So Priya, இப்போதைக்கு அந்த the other battery we have to put it here and share. Okay. Okay, guys. Chitra, let me share the screen. Just a minute. This is that I'll see.
కొంచెం లేసా ఫోకస్ పిల్లలు కూర్చో
அந்த அதர் பேட்டரி கொண்டு இதுல போட்டு பார்க்கலாம்.
இல்ல இப்பதான் சார்ஜ் பண்ணிருக்கேன்.
இதுதான் சார்ஜ் பண்ணிருக்கேன். Let's see. Okay, guys, I'm shifting to the camera view. And let me try again with the telescope view in a while. Okay, just give me a moment. Oh, Prabhu, going to charge it. Chitra, you can pull out the screen where I focused on Saturn and Jupiter in the camera view. I'll zoom out and show how it looks like. Now can you see? It's too small, that the separation between them. Chitra, is it just let me know if it is visible, the camera screen?
The screen is not visible.
Not visible. Okay, I'll do it. Yeah, just give me a moment. Check now, Chitra.
Yes.
If you guys are able to see the conjunction from where you are, please let us know. I'll try to zoom in. Right now it's a zoomed out view. Let me zoom in and also show you. Now I've zoomed in and you can see those two dots more clearly. Chitra, correct? You're able to see it?
Yes.
Yeah, is it visible there? No? Okay, guys. So let me explain you. I'm sure still you're able to see it. From where I am, I'm able to see it beautifully. Um, so let me explain you a little bit about this conjunction. Okay. So every about every 20 years or so, the planets get into something called as the conjunction, like the one that we see today. Okay. So every 19.86 years. But this year, it is extra special because they have gotten much closer than ever before. I mean, not ever before, but at least in 800 years. So every 20 years, so why do they appear to get close to each other in the sky? Are they actually getting closer to each other in the sky? No, they are not actually getting closer to each other in the sky. It is just from our vantage point, they appear to get closer. So let me give you an analogy of what is happening, why they appear to get close to each other. So now, if you are in a racetrack, let's say, let us for convenience, let us say it's a circular racetrack, okay, and there are multiple lanes. The closer one, the first lane, second lane, third lane, you can imagine that circular racetrack to be that of first of all, am I audible, Chitra? Am I audible in what I'm talking?
Yes, yes.
Okay, right. Thank you. So I wanted to ensure that. Right. So let me bring that into views so that you can see it. Okay. So now imagine a circular racetrack and compare it to a solar system. Solar system, you can imagine the planetary orbits to be different lanes and the central point to be the sun. Okay. And imagine in every lane in the circular track, there is a car that is going around. And imagine that to be a race, okay? And there is a rule. When it comes to planetary orbits, the ones that orbit closer to the sun will move faster around the sun. Like, for example, Mercury takes about 88 days and Venus about 225 days. Earth, we define the year based on the number of days the Earth takes to go around the sun, 365 days. Then so on and so forth. Like Mars has 687 days and Jupiter has about 11 years. And Saturn is roughly 28 or 29 years. And then you have Uranus at 84 years, Neptune at 150 or 164. And Pluto, if that was supposed to be called a planet, it takes about 248 years. The pattern is clear. The closer you orbit to the sun, the faster you move around the sun. Okay, let us keep a similar rule in a circular racetrack where the cars are moving around in different lanes. The one in the closest lane, the innermost lane, that car will have to travel faster. The further you go from the innermost lane, let's say that cars move around the track at a slower pace. The car at the final lane, the last lane, the outermost lane, will be the slowest. Okay. Now, let us say there are 9 lanes or 8 lanes, similar to the planetary orbits. Okay. Now, me being the Earth, I'll be in the 3rd lane, and Saturn and Jupiter and Saturn will be in the 5th lane and the 6th lane. Correct? According when you compare it to the solar system orbits, 5th lane and 6th lane. So now, between 3 of us, Earth, Jupiter, and Saturn, Earth moves the fastest around the sun. Jupiter moves the 2nd fastest. Okay, it is slower than Earth, but it is faster than Saturn. And of these 3 planets, Saturn will be the slowest of all. Correct? Now, we are all moving around the sun, and Earth takes about 1 year. Okay, so now let us say in the case of the cars in the 3rd lane, 5th lane, and 6th lane, every 1 year, let's say, or every, let's say, 10 minutes or so, let's say the 3rd lane where I am in, I complete 1 lane in every 10 minutes. While Jupiter, let's say, it completes every half an hour, it is able to complete 1 lane, one lap. And Saturn, let's say, it takes even more time. Let's say it takes about an hour or 2 to complete 1 lane, 1 lap. So now every lap that I make, it is like at some point during the circular track, some point in the circular track, I will overtake Jupiter. Okay, at some point in my track or motion around the circular track, I will be overtaking Jupiter. Right? Is it clear, Chitra? Am I being clear? At some point in time, I will be overtaking Jupiter because Jupiter is moving slower around it, and I am moving faster. So I will overtake. And how frequently will I overtake depends on how fast I move and how slow Jupiter moves, or the car in the 5th lane moves in this case. And similarly, Jupiter, or in this case, the car in the 5th track will overtake the car in the 6th lane, right? Because the car in the 5th lane is going to move faster than the one in the 6th lane. So, okay, now today what is happening is that it is a race between 2 planets, Jupiter and Saturn. It's just like in the cars between the 5th track and the 6th track. And the car is in the 5th track, which is in this case, the Jupiter is overtaking Saturn in its orbit. That is exactly what you're seeing in the sky right now. We are at the moment where Jupiter is just about overtaking Saturn in the night sky. From our point of view, like we are also moving around the sun, right? So we being like in the 3rd lane in the car, we are just lowering our windows and looking at the 5th lane and 6th lane. We're looking from our 3rd lane, looking at the car in the 5th lane, overtaking the car in the 6th lane. Okay, and what will it appear? What will the cars appear like when they overtake? When the car in the 5th lane overtakes the car in the 6th lane, they'll appear to be closer to each other. From our point of view, they're going to be very close to each other because they're overtaking. If they're not overtaking, they'll be wide apart from our view. So that is exactly why you're seeing them to be too close to each other in the sky, because they're overtaking. Okay. Now, as you go further from today, like tomorrow, the day after, and few weeks later, Jupiter would have comfortably overtaken Saturn. Now, in the coming days, you will see that they're widening. The gap between them is widening apart, which means like Jupiter has gone way beyond after it's overtaken. So now this is exactly what we call as the conjunction. Okay. Every 20 years or so. So the reason I'm talking about this overtaking, comparing with the car on the lane, is that every 20 years or so, Jupiter will overtake Saturn. Because Jupiter takes about 11 years and Saturn takes about 28 years. So Jupiter will come back to the same spot where it is today in 11 years. But by the time Jupiter comes back to the same spot in 11 years, Saturn would have moved further ahead, right? So to catch up to Saturn, it has to take further, like let's say another 8 years or 9 years more. So adding up to 20 years roughly. So before Jupiter can overtake Saturn again. So every 20 years or so, Jupiter is going to overtake Saturn. Okay, so they will appear to be closer to each other in the sky every 20 years from our point of view. But why is this particular event special? Why is this particular event special? Is that when each time Jupiter overtakes Saturn, sometimes our vantage point, like what is the gap between those two cars, also depends on where is the Earth around in its orbit, right? Where am I in my third lane? What is the position of the car in the third lane when it observes when they get close to each other and when Jupiter overtakes Saturn? So when everything lines up perfectly, okay, then the gap between Saturn and Jupiter appears to be extremely close to each other if our position in the third lane happens to be in that position where you can see them close to each other. So that is the reason why today's event is extremely rare. Like last time they got so close to each other was in early 17th century, but last time it was possible to be seen with the naked eye was in 12th century. But luckily, the next time they're going to get as close as you see them in the sky today is in 2080, about 60 years from now. Now, here's an interesting thing that you can note. Did I say 60 year 2080? So how long does it take? Is it from today? 60 years. So when you look at that, 2020. So in after 20 years from now, it will be 2040, right? In 2040 also, you will see Saturn and Jupiter close to each other in the sky, but not this close because Earth is not at the right vantage point. Now, after 20 years from 2040, 2060, even in 2060, they'll get close to each other in the sky, but not this close. Remember, every 20 years, I said they will get close to each other. But 20 years, even after from 2080, which is to say 2080, 60 years from now, again they will get close to each other. But that time they will get as close as they have gotten today. So that's the best part about 2080 again. So now I hope I've given you some clear information on how long it takes for how this entire planetary conjunctions happen, and what you're seeing today is an extremely rare event. So please keep observing while I bring back the view of Saturn and Jupiter through the telescope. So Chitra, have I made myself clear in whatever I've communicated so far in terms of conjunctions?
Yes, I think there was one question as well.
If there are any questions, please let me know as I shift to the telescopic view of the planets. Just give me some time as I move around. Just shoot the questions as you have.
Yeah, there's someone asking how long will it take all of the planets to line up?
Oh, that is an extremely rare event for all the planets to line up. It's probably in hundreds of thousands of years. Um, so what you're trying to say is when all of them line up, it's like you will see all the planets together, like in a sky, in a small patch of sky, like too close to each other. So that's what you may assume, but that is an extremely rare event. So that's not going to happen anytime soon. Yeah, but that's probably, I don't have a number right now. Yeah, Chitra, if there are any other questions, please let me know. Right now, I'm going to shift to the telescopic view of it. Okay? Yeah.
All right.
Please ask your questions. I'll be glad to answer them. Okay, let me, as you guys are looking at the view, Chitra, it's still visible, right? The through the camera view, right?
Yes, yes.
Okay. Right now, I'm trying to shift to the telescopic view. Give me some time. In the meantime, they can keep looking at this one. Yeah. Yeah. Where is it? Where is the wire? Wire banana. No, it's fine. Remote shooting and no. Yeah. Now tell if it comes. Okay.
The corner of the building. Yes, yes, yes. Stop, 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 stop. Looks excited.
Good.
We have a question of it.
Yes, Chitra, please ask me.
There's a person asking what is the best place to experience this day and what time for the UK?
Chitra, I'm not able to hear, Chitra. Yeah, tell me now.
Which is the best place to experience it today?
This event.
Yes.
Look, right now, since both the planets are like quite bright, you can see it from anywhere. But for any astronomy-based events, choose a place that has very low light pollution and very clear view to the horizon. So that would be the best place to see. So yeah, low light pollution. Move away from the cities. Further away from the cities you are, it is better. So Chitra, I've put the telescopic view again. You see if that is visible. I've put it. It's getting dimmer, but hope you're able to see it. Chitra, you able to see it? The
Yes,
other
yes.
screen. Is the ring anywhere like possible? It's visible
The ring
of
is
the
not.
Saturn. Ring is not visible.
No.
The ring is not visible, is it? Okay. I'm trying my best to see if the rings can be shown because in live view I'm unable to zoom in somehow. Let me see if I can zoom in.
Okay, there's somebody asking how are the two planets getting really close?
What, Chitra? Can you repeat it?
How are the two planets getting really close?
No, they're not in reality getting close to each other like that. Like I told you, it is like two planets are still separated by several millions of kilometers. Okay, still on even today. But today is when Jupiter overtakes Saturn in its orbit because Jupiter moves faster around the sun than Saturn. And from our vantage point, when one object overtakes another object and we are looking at it, how will those two objects look to us? They look like they are close to each other, right? That is exactly what is happening to them. But in reality, they're not close to each other. They're separated by several million kilometers. Yes. So does that answer the question, Chitra?
Yes.
Chitra, are you able to see the zoomed in view? I'm zooming in. Can you see it?
Jupiter is visible. Saturn is
No,
extremely dim.
I'm going for a live zoom, but you're not seeing the zoom in, right? I'm
No,
zooming into my camera, but you're not able to see the zoom in, right, on the screen.
no, it's not visible.
Sorry, I'm unable to. So, but what you're seeing right now is okay. So now this is a very interesting day where they've gotten really, really close to each other, but I'm unable to show you probably the moons of Jupiter as well. I'm not sure if you're able to see the moons of Jupiter. Okay. Okay, so that is the view that you're able to get. Let me, Chitra, if you have any questions, just ask me. In the meantime, I'll try to see if I can go with a higher magnification. Just give me a moment. I'm going to try. So now that you've seen with this magnification, let me try attempt a little more higher magnification. Okay, it might take another 5 minutes, but I will try. You might best attempt. Just give me some time. Yes. Uh, Chitra, you can focus on the other camera if it is there. Yeah, but you can pull out the other camera view right now. No, 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 please.
Indian தெரியுமா
Chitra, are there any questions, Chitra? I would like to take them.
There's none so far.
Okay, so let me tell about then. If there are not any questions, I'll probably tell a few interesting information about these planets. So Saturn and Jupiter, like most of you know, are the two biggest planets. They call it the gas giants, mostly made up of hydrogen and helium. And Jupiter being the biggest planet in our solar system. Okay, and Saturn is the second biggest planet. Okay, just give me a moment, Chitra. I'm trying to focus on. Okay, let me focus on the moon for a moment. You can see the craters. Give me a moment, Chitra. Yeah. It right now. Are there anybody observing it? Chitra can ask them if they're observing it. If you have a binocular, you please do observe it. Haven't I observed them myself yet?
Yeah, I think a few people are able to see it clearly from the terrace.
Yeah. Yes. Are they able to resolve it into 2 points? I am able to see it from here, like with naked eye, because that is a challenge. Most of them would, with naked eye, would be able to look at that like one single point only. But yeah, but still it's interesting to see that people are able to actually see them as two different points. Some of them may find it challenging though. So as I was talking about this Saturn and Jupiter, they both are gas giants, and most of them they're mostly made up of hydrogen and helium. Hydrogen to a larger extent, helium to a lesser extent. And these two gas giants, and if you are looking at the sky, you look the moon. It is half moon, like almost half moon today. And right overhead, if you are all observing the night sky today, right overhead, do you see a bright red dot, a point of light? Chitra, see if they can observe it. Right overhead, there is a bright point of light that does not twinkle. Are you guys able to observe it? If so, you can let me know.
We have one common sense that the person can see the rings of Saturn.
You can see the rings of Saturn. Okay, interesting. I mean, maybe when I showed them, it was there. Um, Now, right overhead, you see a bright orangish dot, just exactly overhead. Okay, and that is Mars, planet Mars. Right now, planet Mars is also visible. Right now on the sky, you can see four objects pretty clearly. One is Saturn, Jupiter, of course, and then you have Moon, and then further up overhead, you have Mars. So Mars is also very bright, and in fact, that's the brightest of the three planets right now in the sky. And of course, that is something that you can observe today as well. And in a while, Chitra, I'm going to show the moon. Okay, I'm going to be showing the moon and also show them the craters. Just give me a moment. I'll be showing them around. Yeah, Chitra, I focused on the moon in one of the it's through a telescopic view. So can you pull that out and show them around? So you can see the craters pretty clearly, beautiful craters on the moon. And I have that. This is the view through the telescope. Unfortunately, it is very difficult to show off the planets because they are too low in the sky, and it's very difficult for the a telescope to pick out the light. But right now you see moon. It's beautiful. It's right. It's a little overhead, and you can see these beautiful craters that you see on the screen. Chitra, it's visible, right? The craters. on the moon?
Yes, yes.
So I'm just showing you around. Yeah, so it is, I'm sure most of you know how those craters form, but let me tell again, let me tell for the benefit of people who do not know. So these are formed by big chunks of rocks striking the surface of the moon and creating the craters, very similar to the craters that you find on Earth. But on Earth, you don't find as many craters as you find on the moon. It's because Earth is geologically active, okay? So Earth has a system, has a weather, it has soil erosion, there is wind, there's a lot of geological activity that erases most of these craters, and it keeps reforming the surface of the Earth. But unlike Earth, moon has no like geological activity or surface activity going on, so it's pretty difficult for any kind of events to erase these craters. So that's why you don't see them. So let me show you a much more wider view of the moon, and I have a very interesting analogy to share. Give me a moment. Yeah, Chitra, I put the wider view of the moon. Are you able to see it?
Yeah, yeah.
You can pull that out. So now you can see, appreciate the extent of craters that you have. It's like really lot of craters. If you observe it more closely, you see there are a lot of craters. Like this amazing amount of craters. This is particularly possible during the half moon. It is easier to observe the craters than during the full moon. So one of the reasons why we prefer observing the moon during its half moon phase is because you can see a lot of craters. So let me reduce the brightness so you can appreciate the contrast better. Is it better now? I've reduced the brightness so that maybe you can see the craters more clearly. Chitra, is it more clear now, the craters, or earlier it was clearer?
It was clearer before.
It was clearer before. Okay, let me increase the brightness. Yeah, so there you go. So that's our moon, beautiful moon. Unfortunately, I can still see Jupiter, but if you have binoculars, you can see it still. But right now they are too low in the sky. Let me see if I can see it spotted using my binoculars. Yeah, I can still see it through binoculars, but I think with naked eye, finding both of them right now is very, very difficult. But let me see if I can show it on the camera, the other camera. So I let me try to see if I can use the camera view. Chitra, I'm trying to bring back the camera view of the other camera. Okay, let's see. Chitra, are there any other questions regarding the conjunction or the moon? If so, let me know.
Yes, there are a couple of questions.
Yeah, please ask them, Chitra.
Yeah. So there's one person asking, do any other planets line up anytime soon?
Do the planets line up?
Do any other planets line up anytime soon?
Yeah, you can imagine this way. So to answer that question, you can think. Let's say, for example, Mars and Jupiter. Mars moves takes almost 2 years to go around the sun, right? So there will be a moment when Mars will overtake Jupiter. Correct? So when Mars will overtake Jupiter, at that time, from our vantage point, they will two appear look like they're appearing closer to each other in the sky. And similarly, other planets like Saturn will overtake Uranus, Uranus will overtake Neptune. Though Uranus and Neptune are too faint to be seen with the naked eye, so every planet, when it overtakes another planet, and from our vantage point, they will definitely appear to get close to each other in the sky. But anytime soon, I have to check. But you understand the concept, right? How they appear to be closer to each other in the sky. So yes, and similarly, this case would be with Venus, for example. Venus can also get closer to, but again, Venus is an inner planet, but still, all the planets can get close to each other in the sky depending on the orbits. Chitra, does it answer the question?
Yes, yes.
Are there any other questions? Chitra, I'm working on the other camera, but are they able to see it? I've focused on it, but is it? I think I've not shared it yet. I think they're too faint to be seen yet. Let me share the screen again. Just give me a moment. Yeah, where is the live view? So they're able to see? No, right?
No, it's not visible.
Just give me a moment. Oh. Chitra, just give me a moment. I'm just trying to see what went wrong because I'm not able to share the screen. Probably the battery is too low. Okay, I think the reason it's not visible is because it's turned off. Yeah. Hmm. Okay, Chitra, are there any other questions? You said there are a couple of questions, right?
Yes. You're asking, will Pluto maybe line up with the planet?
Pluto, yes, Pluto will line up with the planet. I think a couple of months ago, Jupiter and Pluto came really close to each other. I think not a couple of months ago, maybe earlier than that. Jupiter and Pluto were really close to each other in the sky. That is when Jupiter overtakes Pluto. Okay, that would happen probably every 12 years or so, 13 years or so. But again, that would not be a spectacular event because Pluto is too faint even to be seen by a powerful telescope that we have. So that is not interesting at all. Even though in principle, yes, it happens, but we can't see it and enjoy it. But Saturn and Jupiter, we're enjoying it because both of them are visible to the naked eye, and that is the reason that we're able to enjoy this. Yes. And let me see if I can give you one last view of Jupiter. I'm not able to see it with the naked eye, but let me see if it's visible. But it has become too faint. I can only pick it up on the. Yeah, Chitra, it is too faint to be seen with the camera.
Okay. What about the telescope?
Hello, Chitra, am I audible? Chitra, am I audible?
Yes, yes, you're audible.
Okay, right. Yes. So, yes, Chitra, I think that's all from my side because I no longer see Jupiter. I no longer see Jupiter. I think you can see my face. That's the last thing you can see, and I have to put a light next to me to make sure my face is visible. Yes, Chitra. So, if there are any more questions, I can take, but otherwise, I think that's all from my side because the planets have gotten so close to the horizon that there is too much of light pollution. I can't see them anymore, and hence I cannot show them on camera or telescope. So, yes, I'd be willing to take questions if there are any.
We don't have any questions so far, but we can wait for a couple of minutes if that's
Yeah,
okay.
sure. I'll wait. I'm willing to take questions, but I can no longer show any visuals because I can no longer see Jupiter. It's too low in the sky. That moment has passed. So once in a lifetime moment has gone, but we have luckily captured a lot of images and videos that I can share later. But yes,
All right, so we have a question. So both the planets are moving in different directions. Are all planets moving in different directions, and how do they calculate which direction they go in?
no, they're all moving in the same direction. Okay, they all spin in the same direction. There are two kinds of directions that you can say when for an orbital motion, for a rotating motion, right? It is either clockwise or the counterclockwise. So depending on how you view the solar system, like either from top or from below. So nevertheless, whether you're viewing it from bottom or above the solar system, so it is in the same direction. All planets move around in the same direction. Their spins are different. Some planets, for example, spin from east to west. Our planet spins from, for example, west to east. But Venus, for example, spins from east to west. And Uranus is tilted on its axis by around 180 or 190 degrees. So the spins are different, but their motion around the sun for all the planets are same. Not just the planets, for every single object in the solar system, be it an asteroid or a comet, whatever it is that is orbiting the sun, it orbits in the same direction, like everything else in the solar system. And of course they calculate it based on their positions. Like for example, today you observe Jupiter, in a few weeks from now or in a few months from now, they'll get further lower in the sky and you won't be able to see them in the evening sky at all. Right now Mars is overhead. If you're observing the night sky, Mars is overhead right now. In the months that follow, the Mars is going to go much closer to the horizon. What I mean by that is right now the time is around 8 o'clock, right? 8 o'clock. At 8 o'clock, you see the Mars is overhead. In the months to come, the Mars is going to move further towards the horizon or further towards the west. And of course, there are a lot of other motions like retrograde motions and things like that. But the positions of the planets keep changing over the months, and they calculate how those positions change and how long it takes to change. Based on these two information, with greater accuracy they collect, they'll be able to predict where the planet is going to be in certain amount of time or after certain amounts of time. And that's how they calculate the speed, the positions, and how long, and also they take into account the motion of earth around the sun. So all these parameters are needed to predict those. Chitra, does it answer the question?
Yes, I think there's also a follow-up question to that, asking why do we see both planets move in different directions?
I didn't understand. Move in different directions. Where which two planets are they talking about? Are they talking about Saturn and Jupiter moving in different directions?
Yes.
No, they're not moving in different directions. They're not moving in different directions. Okay, one planet is overtaking another planet. Okay, when one planet overtakes another planet, you will see them move apart, right? The separation between them. Saturn is also moving in the same direction as Jupiter, but Jupiter is moving faster. When it moves faster, it gives an illusion. The since two planets are the space between the two planets are increasing every day, it looks like both are moving away from each other, which is to assume that they are like moving in opposite directions. It's an illusion that they're moving in the opposite direction. In reality, Jupiter is just overtaking it. It's just like, one car in the lane, let's say fifth lane, overtaking another car in the sixth lane. When the car in the fifth lane overtakes, the gap is going to be very minimum at the moment of overtaking. And after it is overtaken, the car will move further up, but the gap between the car in the fifth lane and sixth lane will appear to get wider and wider. But the car in the sixth lane is still moving in the same direction as the car in the fifth lane. But the gap between them is widening. It gives an illusion that they're actually moving away from each other in the opposite direction. But they're actually moving in the same direction. Does it answer the question, Chitra?
Yes, yes.
Yeah. So they're actually moving in the same direction.
Okay. So the next question is, does this conjunction have any gravitational effects on the Earth or the Moon?
No. So of course, every planet, like Newton's laws of gravitation, you may have learned like every object attracts every other object in the universe with the force of gravity, but the amount of gravity that they exert on us is practically minimal. Like, the amount of gravity that we are subject to by our own Earth is way higher. Sun, for example, and when these planets line up, the gravitational effect, in principle, yes, but it has absolutely no significance. There is no effect whatsoever because the value is like absolutely insignificant value. There's no effect. For example, to give you a comparison, the force exerted by other objects in your everyday life, for example, let's say you get hit by a football, or you the amount of the force with which you sleep, the press against the pillow when you sleep, those forces are like way higher than the force of gravity from these planets that are very, very far away. The force of gravity reduces as the distance, square of the distance between the objects, and also the masses of the object. So we are like practically insignificant. The force on Earth is practically insignificant. So you don't have to worry about it. But if you talk about mathematically, in principle, yes, but it goes in the order of like very, very minuscule amount, like several orders less, powers of 10 less. So it has no effect at all. So don't worry about the gravitational effects at all. Does it answer, Chitra?
Yes, thank you. We have three more questions. One is,
Yeah.
are there no hard surfaces on Jupiter and Saturn since they are gas giants?
Chitra, can you repeat the question?
Yeah. Are there no hard surfaces on Jupiter and Saturn as they are gas giants?
Yeah, so it is predicted, or rather, there's a hypothesis that which the people are trying to gather evidence that the core of the planet Saturn and Jupiter, at least Jupiter, because being it a more massive planet, it has got metallic surface, metallic hydrogen. You call it hydrogen in the solid form, okay? Because the core of Jupiter is under tremendous pressure and heat, okay? Tremendous pressure, that hydrogen exists in solid form, or as they call it, metallic hydrogen. But no one has been able to peer through and go through the atmospheres of Jupiter to actually see if there is a solid surface. But according to the theoretical calculations and the hypothesis, there should be a solid surface that exists that at the core of the planet. People call it metallic hydrogen, hydrogen in solid form. Yes, but for most part of the planet, yes, it is gaseous planet, gases, hydrogen and helium gases predominantly.
Okay. There's another question saying, how long do Jupiter and Saturn take to go around the sun?
Yeah, Jupiter takes about 11 years and Saturn takes about 28 years, 28 or 29 years. I'm not sure of exactly, 28 or 29 years. So for every, let me give you another interesting comparison. For every, okay, let's take Jupiter takes 10 years. It takes 11 years, but for ease of calculation, let's say Jupiter takes 10 years to go around the sun once and Saturn takes 30 years, okay? So it's in the ratio 3:1, roughly. So for every orbit, one full orbit that Jupiter makes, Saturn would have covered 1/3 of its distance around the sun. when Jupiter makes 2 orbits around the sun, Saturn would have covered 2/3 of its distance around the sun. When Jupiter completes 3 orbits around the sun, Saturn would have completed 1 orbit around the sun. So, I mean, it's not exactly right, but you get the point. So 11 years for Jupiter and about 28 or 29 years for Saturn. That's how long they take to go around the sun.
Okay, thank you.
Are there any other question?
As of now, there is no question.
There's
There,
some
someone
question
had
like,
actually asked if Earth lines up with other planets, will we be able to see that conjunction? So practically, we wouldn't be able to see it, but how close or how far will the other planet
look,
be?
if you want, we will be definitely a part of conjunction. For example, if there is some alien life form on Venus, and from Venus perspective, Earth and Mars can get close to each other in the sky, or Earth and Jupiter can get close to each other in the sky. So for us to be visible in somebody else's night sky, okay, so since we are on Earth, we can't see ourselves to be, we can't imagine ourselves to be how we would look from outside of Earth, right? So if we are on, let's say, Venus, and then it is like a very interesting sight to see Jupiter and Mars, get into conjunction every few years, maybe 3-4 years, they will get into conjunction from Venus point of view. Or if you are on Mars, then Earth and Venus will get close to each other in the sky from Mars's vantage point. It is very interesting to see how we would look at from someone else's night sky. That's an interesting question, but yes, Earth will definitely be a part of a conjunction, but only that we won't be able to see it if we are on Earth. We'll have to move to another vantage point to see Earth being part of another conjunction. But yes, we'll definitely be part of a conjunction.
Okay. I think that was our last question. There aren't any more questions.
Okay, so probably I can show the moon for one last time, Chitra. Probably the moon is really good, and probably if there are no questions, then
Okay, I think there's one more question that has popped up.
yeah, please ask any question. Don't leave any question unanswered, Chitra. Even if it's a repeat question, because there might be people who are looking at it who it's for the first time. So ask any question that is there. Please ask.
Yes. So is the conjunction that we are seeing today actually an event that took place millions of years back because of years required by light to travel to us?
Yeah, very interesting question. But Jupiter and Saturn are not that far away. Okay. For example, I'll give you a comparison. For the sunlight to reach Earth, I'm sure all of you learned in school it's about 8 minutes, right? So that's long it takes. So light takes about 8 minutes to reach from sun to Earth, or you can say sun is at 8 light minutes distance away. Okay, 8 light minutes. Saturn is at probably, Mars is at probably 15 light minutes, or maybe 20 light minutes. Jupiter maybe about 30, or let's say 1 hour. I'm not sure. So it takes about only minutes and hours for the light to reach from Saturn and Jupiter, not millions of years. When you talk about millions of years, you're talking about another galaxy. For example, Andromeda galaxy, which is our closest neighbor, it is at a distance of about 2.6 or 3 million light years away. If some event is happening in Andromeda galaxy, then the light would take so long to reach us, about 3 million years to reach us. But for Saturn and Jupiter, they're very close by. It probably happened about 30 minutes ago, 30 minutes or 40 minutes ago. I think even that is maybe 1 hour. I'm not sure exactly. But that's all. It should be about an hour or so. So what we're seeing, Saturn and Jupiter right now, is about they were 1 hour ago, because that's how long it takes for the light to reach from them, not millions of years.
Okay. There's also a question saying, can any
other
planet
planets
conjunct
with the sun? Okay, it's a very interesting question. Conjunction with the sun. Yes, planets can get closer to the sun in the sky. Again, from our point of view, let's say we have sun and Jupiter and Saturn on one side and Earth on the other side, because we're all orbiting the sun, right? At some point we'll be on one side of the sun. Saturn and Jupiter could be on the other side of the sun, right? So from our point of view, when the Jupiter and Saturn, for example, let's say Jupiter, for example, Jupiter is on the other side of the sun, and we are on this side of the sun. Then from our point of view, Jupiter will be very close to the sun, but we won't be able to see it, because since Jupiter is going to appear very close to the sun in the sky, it will be during the daytime, and the sun is going to be so bright that even though the Jupiter is very close to the sun in the sky, we won't be able to see it, unless, for example, during total solar eclipse. Let's say Jupiter is very close to the sun in the sky, and normally we won't be able to see it, but let's say on that particular day it's a total solar eclipse where the moon comes and blocks off the sun. Then the sky darkens at that particular moment, where enabling the Jupiter to be visible. So it's only during the total solar eclipses, if any other planet is close to the sun, we'll be able to see. Otherwise we won't be able to see, but it is very much possible that we will be able to see other planets conjunct with the sun. But all the planets, outer planets, will go behind the sun from our point of view, right? Because sun is there, they're getting to the other side. But two planets called the inner planets, they won't go behind the sun from our, they will in fact sometimes go behind the sun. But it is also possible that since Venus and Mercury are inner planets, they can go in front of the sun, just like how moon can move in front of the sun creating an eclipse. Venus and Saturn, Mercury can move in front of the sun. We call such events planetary transits. Planet transiting in front of the sun. Venus transit and Mercury transit. Those are very, very rare events. In fact, we at Mango Education saw one such a transit last year from Mauritius on November 11th, 2019. The next such transit happens in 2032, which is also visible from India, when planet Mercury will be moving across the face of the sun. Okay, because from our point of view, Mercury orbits closer to the sun, right? So from our point of view, it can move in front of the sun. That is also possible. You can call it a conjunction, or you can call it a transit. Okay, so that can also happen. Venus transits also happen, but they're even more rare. Okay, the next Venus transit is known to occur in probably a century away from now, so not possible in our lifetimes. Yes, that was the answer to the question, conjunction with the sun.
All right. One more question has come up.
Chitra, I see another question.
Yes.
Why is that we are able to see the planets with the reflection of sun of light from the sun, but we do not see the interstellar? Okay. So interstellar space is mostly like vacuum. It's not literally vacuum. There's particles here and there. Okay. For us to see an object, there should be enough light reflected off it. Okay, enough light. For example, if you look at the night sky, there are a lot of asteroids and small pieces of rocks also orbiting the sun, but we're not able to see any of them right now, except for these giant planets like Saturn, Jupiter. For example, we're not even able to see Uranus, Neptune, or Pluto with our naked eye. Why? Because even though they reflect sunlight, it is not enough light for us to see it. That is for even for a planet like Pluto, or sorry, a dwarf planet like Pluto, or even you pick up any asteroid or something. Even though I have a quite sizable chunk, let's say 1 kilometer rock, or probably a few kilometers diameter, some piece of rock that is orbiting the sun, it does not reflect enough sunlight to be seen by us. Then imagine the interstellar space. Interstellar space is probably filled with dust, at hydrogen atoms and helium atoms here and there, and they're practically nothing. They're like size of like few centimeters, like a group of particles, or probably microns across, a few nanometers to femtometers. So that is not size enough for them to reflect light at all for us to see it. And that is why you see the interstellar space to be dark. You don't have enough particles to reflect light. You need a sizable chunk of particles that two together, for it to be visible to us. Does it answer the question, Chitra?
Yes. Okay.
I'm also checking if I've left any question. Any other question, Chitra, that we have not answered? Okay, that's all. I think right now both the planets have set The setting time was around 8 o'clock. Right now it is past 8. So both Jupiter and Saturn have set. So do not worry. It is not like you're going to see Saturn and Jupiter only for today. Even tomorrow they're going to be there. Like by around the same time, 6:45 or 7, you will see, look at the night sky, you will see them. But the gap between them would have increased. Okay, they wouldn't be as close as they were today. So tomorrow Jupiter's already overtaken Saturn and it started going, the gap between them would get wider. And it is an interesting experiment or observation that you guys can make. Observe for the next coming week, entire week, okay, every day. And after a week from today, you see the gap between them would be significantly bigger, which means they're like separated quite a bit in the sky. So that will be very interesting to observe. Yes. Yes, Chitra.
We got another question.
Yes.
So someone is asking if the Pioneer space probes, where are they now?
One of the Pioneer probes is, I think, out of the solar system. The Pioneer 10 and Pioneer 11, those are the two space probes. Both of them are way past they're way past Pluto. Like one of them is probably entered interstellar space, but I'm not sure which of them, Pioneer 10 or 11. But both of them are going in completely different direction. Okay, but as far as I know, at least one of them is out into interstellar space, or probably very close to there. They're way beyond the orbit of Pluto, like way beyond the orbit of Pluto. Both of them, Pioneer 10 and Pioneer 11.
Okay. Is the conjunction also still visible? Because I think a couple of people are asking if
right now, as of today, it is no longer visible because both the planets have set, meaning like they're below the horizon. They're below the level where you can see. It's no longer in the sky where you can see. But tomorrow, at the same time, around 6:45, 7, you can still see the conjunction. But today was the great conjunction because they were the closest. But tomorrow and in the coming few days, you can still see them close to each other in the sky. For sure.
Okay.
But for example, if you are not from India, if you are like from some other part of the world, for you, it is still visible in the sky. I'm talking only from my place, Coimbatore. For some of you, it is still evening, right? For some part of the world, it is still 6:30. The sun is just setting. For some part of the world, the sun, as I speak now, the sun is still setting. Okay, for those part of you who's still in the evening, for whose time is still 6:45. At some part of the world, the time is still 6:45, right? Those of you can still see it. Okay, when I say you can't see it anymore, it's only from my region because the sun has already set and the planets have already set. For some part of the world, it is still visible. Yes. Let's for example, people who are behind us, let's say United States of America or Africa, some other countries, it is still yet to be evening. They'll see it in few hours from now after the sun sets from their local time, local region.
Okay.
Is the conjunction ongoing? Yes, it is ongoing. Right now, it is still there, but it's not visible to us because it is both of them have set. Chitra, was that clear?
Yeah, there's also a question asking in the US, is there any website or something where one can view this online?
I'm sure there. You just go to Google, you search. I'll try to find the link and send you, but I'm sure NASA or some other major US. I'm sure a lot of people are doing it. I'm sure a lot of people are doing it in US. I can try to source something and let you know. Just give me some time. Probably we can send you some message or something. But NASA should be telecasting, I'm assuming. NASA. But you go to Google and check. There will be a lot of people who are doing it.
Okay. I think the questions have ended with that one, probably.
Okay, Chitra, I think yes, I'm glad the skies cooperated today for us to see both of them in the sky. Initially, I think the telescopic view was not, the rings were not clear because they were too low in the horizon. It was difficult to get them, and but still, I think it's a great moment that both of us were able to, both the planets were able to be visible in the single frame through the telescope. Yes, that was really good.
Okay. So with that, I think we can close because unless there are any more questions, which I don't see.
Yeah. Okay, Chitra, I think we can end the session then.
Okay,
Middle East.
I think
What is the time in the Middle East right now? I don't know. Middle East is probably few hours behind us. Middle East, few hours behind us, right? About 1 or 2 hours. Yes, if you are in the Middle East, yes, you can see it now. I think it's still evening for you guys, right? Uh,
yeah, it's about
yeah,
5:45.
5:45. So you check out your local sunset time. What is the sunset in your local? You can view 45 minutes after sunset. That is when the sky will be dark enough from where you are. So if you're in the Middle East, yes, you're still good to go see them. But also, please look at the local sunset time. 45 minutes after the sunset time would be the best time to observe.
Okay. There's a question by Ramsey saying, at what point size does a planet become a star?
At what point of uh, we can we can compare it with Jupiter. Okay, Jupiter, like little more massive, like tens of for 20 more Jupiters. Jupiter were like 10 or 20 times bigger or more massive, it would have become a star, a small star, of course, but just a rough number. Okay, Jupiter is like the biggest planet we have. If that were little more, like I'm not sure if it's 20 times more massive, but 10 times more massive, maybe it could become a star. I mean, this is just a rough number that I'm just throwing it out there. Yeah.
Okay. That's it, I think, hopefully.
Yeah. Okay, Chitra. Then thank you. I hope there was a lot of interruptions in between. I'm really sorry, but I'm glad we all were able to. The skies were clear, and we were able to actually see the planets, both of them, really close to each other in the sky. And I'm glad we did. Yes.
Okay. Thank you so much, hopefully.
Thank you, Chitra. Thank you for conducting this despite my adventure here with the camera and the telescope. Thank you so much. Yeah. Thank you. See you all. Yep.
Thank you, everyone, for participating. We'll see you in the next live.